So I left in basic function notation. I'm probably going to change this up on the next one just a little bit, but still working with numbers. Anyways, for some reason, if you still haven't understood these, this is saying find y when x equals -3. So we're just going to let this x be a -3. There's an x, she becomes a -3. Exponent is a 2, minus a 7. If I take a -3 and I square it, I'm going to get 9. And 4 times 9, last I checked, was 36. And 36 minus 7 is 29. So it turns out f of -3 is 29. Moving backwards again, one of these solve for x's. And these are not too hard. Because of the mixed variability in this, and it's not a quadratic, it doesn't have x squareds, we're going to get our x's on one side, we're going to factor, and we're going to divide. That's exactly what we're going to do. So let's write that out for you. Everything with an x on the left. Factor, divide. That's all there is to it. So 8x has an x. We're going to leave it where it's at. This guy has an x. It's going to move over. It's going to change its sign. 9 doesn't have an x. We leave it in place. 3y shifts over. Ta-da! There we go. Now, usually when we factor, we pull things out, we pull out as much as we can, but not in this case because all I want is an x. So I'm going to leave a lot more in place than I usually do. X times 8 is 8x. X times 6y is 6xy. This one's going to need a little more simplification than some of the ones I've done with you all in the past. But the opposite of multiplication is division. And I'm going to change order here just so it looks better. Since they're both positive, I'm going to leave the 6y out front. And if I divide one side by 6y plus 8, I have to do it to both sides. And I was wrong. This one does not need simplification. I thought it might, but it doesn't. Now, what you could see, like on the ACT, you might see this. Both of these are divisible by 3. Both of these are divisible by 2. You might see somebody do something like that. But really, no. This is good enough. Oh, going backwards, right? On to number 5, solve by completing the square. Now, you've got a set of instructions off to the side. I don't know why I didn't put them in notes. But this is how you complete the square if you can't do it in your head. I was taught to complete the square mentally. And this is really how you do it mentally, to some degree. It's kind of hard to explain because, if people do it mentally, they have pretty good grasp on their multiplication tables and stuff. But we are taught to do it mentally. We were taught to stare at it and think. And apparently I spelled mentally wrong. I spelled mentally. Let me fix that. Won't matter because I've already misspelled it on your piece of paper that I made copies of. But there we go. All right, first thing you do is you divide all things by a. So everything gets divided by a 3. X squared plus 4x minus 2 is 0. Move the constant to the right-hand side. X squared plus, that's a really bad square. X squared plus 4x equals positive 2. Notice the space I left? It's because of what's about to happen. Now, you're supposed to find half of b. This is your b value. B is 4. Half of it would be 2. You're supposed to square it and add to both sides. So it's going here, and it's also going here. You have to add to both sides to maintain balance. The right-hand side is going to add to 6. The left-hand side factors. Factors of 4 that add to 4 are both 2 and 2. because 2x and 2x makes 4x. Now, if something's written twice, that means it was originally squared. Now, pay attention to this because there's a lot of shortcuts on this. You had a 2. It ended up right there. Always does. The opposite of squaring would be to take the square root of both sides. Now, I don't know what the square root of 6 is, and I don't care what the square root of 6 is. I'm going to leave it square root of 6. I'm not going to be pushing buttons in a calculator. Now, where was I? A square root and a square cancel each other out. It's because the square root actually has an understood 2 here and then disappear. And I'm left with x plus 2 equals plus or minus root 6. Now, why the plus or minus? Because I had an exponent of 2, so I had 2 solutions. The opposite of addition is subtraction, so negative 2 plus or minus root 6. Now, you might see this given as 2 distinct answers. You might see that x is negative 2 plus the root of 6, or negative 2 minus the root of 6. It's one of the two. Let's complete the square method. This method is ancient, and it is the method that I use to do these things in my head. I don't do the quadratic formula in my head. I might factor in my head, but that didn't factor. So I actually am a big fan of completing the square. Solve using the quadratic formula. All right. So you can sing the quadratic formula one of 2 ways. You can go x equals negative b plus or minus square root b squared minus 4ac all over 2a, which is row, row, row your boat. Or you can do pop goes the weasel, which I just sang row, row your boat, so now I'm probably all x equals negative b plus or minus square root b squared minus 4ac all over 2a. Pick your poison. But this is the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, where do you get a, b, and c? You get them from knowing standard form. And you do a lineup process. That's really all there is to it. A is 2, b is negative 3, and c is 1. And then you just throw them into this formula. So opposite b, or negative b, a negative times a negative is a positive. Square root b squared minus 4 times a, which is 2, times c, which is 1, all over twice a. I plugged into the formula. Now I'm going to crank out the math. Me and pretty much every other math teacher I've ever seen do this, we start here. That's what we do. We do the inside. We do this piece called the discriminant. I don't know if I'll talk about that tomorrow. It just depends if I remember or not. Negative 3 squared is going to be positive 9. 4 times 2 is 8 times 1 is 8, so minus 8. All over 4. Now, 9 minus 8 is 1. This becomes root of 1. And both pieces are over a 4. The square root of 1 is, believe it or not, 1. Some kids leave it like that, but it's 1. This is 3/4 plus or minus a quarter. And then we break off and we do the math. 3/4 plus a quarter, or 3/4 minus a quarter. Now 3/4 plus a quarter, if we take 3 and 1, we get 4/4, which is 1. 3/4 minus a quarter, we get 3 minus 1, which is 2. So 2/4, which is 1/2. So x is either a half or x is 1. That's the quadratic formula. These, by the way, are again your x-intercepts. Now this thing would have actually factored. It would have. If you get nice answers, it would have factored. But I wanted you to do the quadratic formula. 3 is a solve by factoring. So you're going to factor it, and then you're going to use the zero product property. I feel like to make a 6x squared, I want to use a 3x and a 2x. Factors of 2 are 1 and 2. I'm going to check myself here. That's negative 4x. That's positive 3x, and 4x minus 3x is negative x. That's how I check myself. So it passed the check. I guessed and I checked. Now I'm going to use that zero product property. I know that 3x minus 2 is nothing, or 2x plus 1 is nothing. Shift the 2 over, 3x is 2, divide by 3, x is 2/3. Shift the 1 over, 2x is negative 1, divide by 2, x is negative 1/2. There's your two solutions. Number 2, if I remember right, is an absolute value equation. And we're going to do the easy stuff first. The easy stuff is to subtract 1. So the absolute value of 2/8. Why did I write 2/8? 1/4 x minus 5 is 7. Now I'm going to write two equations. 1/4 x minus 5 is 7, or change sign, negative 1/4 x plus 5 is 7. Notice how both signs change? That's how it works. That's just how it is. Anywho, do easy stuff first, kids. If I add 5, I get 12. If I take away 5, I get 2. So 1/4 of x is 12, or negative 1/4 of x is 2. The opposite of dividing by 4 is to multiply by 4. 4's cancel. X is 48. Same thing over here. You do it to both sides because you understand balance. 4's cancel. Negative x is 8. Divide out the negativity, and x is negative 8. There's your two answers. They're not the same, but yet 1 in probably 10 of you guys is going to pick the answer choice where they're the same number with different signs, because you're too hard-headed to realize that that's not how it works. And the first one, the easy one, solve for x and always simplify fractions. So let's just do this the way Buckley has you do it, even though we don't agree in high school level. We'll just shift this over here. We'll have 3x take away 9x, which is negative 6x. I don't know why I wrote 3x. But 3x take away 9x is negative 6x. And then we're going to add 8. Negative 15 plus 8 is negative 7. And we're going to divide. I made another mistake until I haven't woke up quite yet today. There we go. We're going to divide by the negative 6. And if you divide an inequality by a negative, the symbolism flips. Why do we do that? That's a good question. Why do we flip an inequality symbol? You've probably never been told. Why does this happen? Because it has to happen. So let's make up a scenario. Negative 6 less than 2, which, by the way, is a true statement. If we divide both sides by negative 1, we would have 6 less than negative 2, which is false. Now, dividing both sides of an equation by the same thing is allowed. It's always been allowed. So to make this true, we flip the inequality. So 6 greater than negative 2, which is now true. We flip the symbols not because somebody told us to do it, but because that's what keeps it true. Anyways, there's the last of the basics practice sheet.